Okay, our next topic, we're going to be talking about molar mass. So again, we're using the concept of the mole. But this time, since we're talking about mass, we're going to be pulling the mass numbers from the periodic table. So remember, mass numbers are the larger number that are on the bottom. So you need to have your periodic table handy to do these. Smaller mass, we're going to add up all the atomic masses in the compound. So just look up the masses on the periodic table and add them all up. Easy enough. First example we'll do together is if I wanted to find the molar mass of H2O. So we have 2 atoms of H. So when I look up the mass of hydrogen, it is 1.01. So if you want to round to like 2 numbers after a decimal point, that would be perfect. There's 2 of those, so you want to make sure to multiply to 2.02 coming from the hydrogen. And we have 1 atom of oxygen. When I look up oxygen, there's just 1. I'm going to round it to 16.0. So we still have the 16, so add them up, 18.02. And we're going to label this as grams per mole. So molar mass, the unit on the end, is grams per mole. My recommendation is to try to keep it to 2 numbers after the decimal point. You don't want to round too soon or too much. Second example, calcium hydroxide. So again, we're going to have to think of the formula. So we have calcium, and hydroxide is OH. Calcium, according to my periodic table, forms a +2 charge. OH is a -1, so I do have to add subscripts, crisscross, parentheses around my polyatomic ion. So my formula is CaOH2. So I have 1 calcium. So that value on the periodic table, 40.01. I have 2 oxygens because that 2 there, remember, goes to both elements that are in parentheses. So 2 times the 16.0 is going to give me 32. And then I also have 2 hydrogens. So 2 times 1.01. So when you're doing your problems, you don't have to show me all these steps. I'm just showing you them so you can go through the process, see how I'm getting these numbers. Let's see. So when we add those up, we're going to have 74.12. So I'm keeping 2 numbers after the decimal point. And then we label it grams per mole. So this is going to become a conversion factor that we're going to use later on. For these numbers, when we're calculating molar mass, we don't need to worry about significant figures. We're really just trying to keep 1 or 2 numbers after the decimal point.